All right, so looking at chapter 3.1 notes. So, it's chapter 3, but just kind of the first third of it, breaking up into smaller chunks for you guys. We're going to be diving into this idea of displaying and describing categorical data. So there's really 3 rules of data analysis, and as you can see, they're very creative with it. Is make a picture, make a picture, make a picture. So things get revealed in a picture that you may not see in raw data, and we'll see some of these examples. It's important features and patterns often will show up, and best way to tell others is a well-chosen picture. The old saying is a picture is worth 1,000 words. Well, that's true in data as well. Think about how you guys all consume stuff. You want it quick, you want it fast. Let me look at something and get all the information I need instead of interpreting numbers within a table. So here's an example from an election. I think it was 2012, I believe. And so red is Republican, blue is Democrat. And so based on the map on the left, who won, red or blue? And based on the map on the right, who won, red or blue, and what's your reasoning? So you guys will have a question to respond to that. Frequency tables, so making piles. So we can pile, so we're going to cram a bunch of data in there, like you see here. This is information from the Titanic, which you guys will see in your textbook, as far as the crew, third class, second class, and first class passengers. And we can count the number of data values in each category of interest. We can organize those counts into A, and then from your reading should be able to fill that in. You'll have that as a response, which records the totals and the category names. A blank, again, you'll find this in your reading, is similar but gives the percentages instead of counts. So you can see here, now instead of just raw numbers, it's a percent breakdown of what those mean. And the way we get percent was we took what the value was, dividing it by the total, just as a refresher on that. So frequency tables, both types of tables show how cases are distributed, and they describe the distribution of a categorical variable. So some category, and often you may have a couple categories within it. And they're good because they actually name the possible categories and then also give us information of how frequently they come up. All right, so I want to answer this question. What's wrong with this picture? So we talked about and saw kind of the raw data of the breakdown of the crew, third class, second class, first class. What is wrong with this picture? So answer in the discussion. And so what was wrong with that is this idea of the area principle. So the ship displays makes it look like most of the people on the Titanic were crew members, with only a few. And when we look at it, what really is important to us, and this is why, is the human eye really looks at the area that is taken up, not necessarily the length of the ship. So the ship display violates the area principle. So in your readings, you should be able to find this answer and then answer down below in the discussion. All right, so a bar chart, which you're probably pretty familiar with, kind of like a histogram, displays the distribution of a categorical variable, and it keeps the area principle true. And so a better display of this, because everything fits together and looks more comparable. So a blank displays the relative proportion of counts for each category. So go and find that. And all we did is we changed the raw data into percentages, just another way to show how things fit together. So again, these displays, looking at that, you get some information right away, even if you didn't necessarily have numbers over on the side. Another way to display data visually is pie charts. You probably have seen these before. And essentially is all of things listed there instead of bars, have it into a pie. So then how are pie charts created? I want you to describe that down below. But we do have issues when you start dealing with visuals. So there's this idea of what can go wrong. So make sure you don't violate the area principle. So what I want you to do is compare these two exact pie charts. What is good or bad about each of them? And how does that relate to the area principle? And then last one, make sure you keep it honest. Make sure your display shows what it says it shows. Okay, so data can lie. You can make data say what you want at times, and we want to be honest and have integrity in our data. And so question is, this plot a percentage of high school students who engage in specified dangerous behaviors has a problem? Can you see what it is? Okay, and I'll give you a hint, there's more than one problem. All right, so for this one, the couple problems you may have. First one is, as you look at this pie chart, if this is 50%, shouldn't that line kind of be straight down? It's not the best straightest line, but should be straight down. Should be half of that pie chart. So that's misleading in that portion there. And then if you add up all the percentages, we have 50 over here, but then if we add those two together, that gives us 58.2%. So total, we have 108.2%. Well, that's more than what the total population should be, since the representation should be 100%. So then that brings us to the next issue, is if you look at what the categories are, so we have marijuana use, we have heavy drinking, and then we have use of alcohol. Well, there is an overlap between those two. So if you're a heavy drinker, you have to use alcohol to be a heavy drinker. So that's where that issue comes into play as well. And I'll answer more questions on this in class if you guys have any. We'll have some practice problems in class and homework to go along with this as well.